Let us have a look at the next topic titled Equilibrium of Forces on a Solid Body. Yes, we are dealing with equilibrium of forces on a solid body now. After this, we'll move to equilibrium of bodies in liquid. Now, what is meant by equilibrium? Equilibrium simply means balance. But some people will mistake it for only when the body is not moving. No. An object can be in equilibrium even when moving. That is, when it is moving with constant speed. It's moving but with constant speed. Constant speed means no acceleration. Such a body is in equilibrium. It can be at rest. Such a body is in equilibrium. Also, a body that is not rotating about a fixed point is in equilibrium. And a body that is rotating but with constant angular speed. Please take note of these words, constant. These are the key words there. Constant. That makes it to be in equilibrium. So whenever the speed is constant, that means there is no acceleration, because acceleration has to do with change in velocity with time. Now, what are the types of equilibrium we have? The types of equilibrium we have are static and dynamic, which can be likened to this definition of or the conditions for a body to be in equilibrium. Static, when we say something is static, that means something that is not moving at all. That is the meaning of static. So that means when a body is at rest, that is, it's stationary, it is experiencing static equilibrium. But when it is moving in a straight line with constant speed, or it is rotating with constant angular speed, such an equilibrium position is called what? Dynamic or kinetic equilibrium. Okay. What are these other things that we need to discuss under this equilibrium? We need to discuss resultant and equilibrant. The word resultant is a familiar word. Of course, that was treated under vector. And that was why I treated vector first before coming to this topic, so that it will be sequel to one another. Okay. Resultant and equilibrant. Resultant and equilibrant are two quantities equal in magnitude but opposite in direction. As you can see in this diagram, look at the direction of the resultant, look at the direction of equilibrant of these two forces, F1 and F2. You can see that these and these are equal in magnitude. That is, they have equal size. If this is 10 Newton, this will be 10 Newton. If it is 5 Newton, this will be 5 Newton. But if this one is positive 5, this one will be negative 5, because their directions are opposite. So that means that resultant is a single force which acting alone. That means if this one is acting alone on this particle here, the effect it will have on this particle is the same effect these two forces, F1 and F2, will have when both of them are acting on this. And the same thing is equilibrant. But when we want to define equilibrant, we will now use the word balance. Let's go there. All right. Look at the definition of equilibrant. Equilibrant is also a single force which will what? Balance all other forces acting together. What are the other forces in this diagram? The other forces are F1 and F2. And you see the direction of F1 and F2, they are facing this right side. But if you look at the equilibrant, it's facing the other side. And you know, when two things are acting in opposite direction and they are equal, that means whatever they are acting on will be balanced. So that means this particle here will be in equilibrium with this equilibrant acting on the body, and as well these two forces acting on the body. Why? Because If this equilibrant is 10 Newton, the sum of these two also will be 10 Newton, as we have it also for resultant. But the only difference is that resultant will act in the same direction with these two others, while equilibrant will act in opposite direction to them. Though I'm only using two forces, it can be more than two forces. Take note of that. The next video will be on three forces acting at a point, which will lead us to what we call triangle of forces. Do not